So I'm going to need to stop sharing here. So there. And I made Larry a co-host, so you should be able to share your screen, Larry.
Awesome, thank you.
Please give Larry a warm welcome.
Thank you, Tony. Thank you, Kevin and Mark, if you're there, for having me back. I ask for apologies in advance. Bear with me. My grandkids gave me a nice head cold, and this is day 12, so I'm still trying to shake it. Let me share my screen here. We'll get started. There we go. Let me share that. Okay, hopefully you can move a couple things around here. See my PowerPoint slide presentation. I'm hoping. All right. Let me go ahead and get started here. Let's see, where did that go? There we go. Okay, so hopefully you can see my banner screen at this point. For somebody just give me a wave, let me know you can see it. I'd appreciate it. Thank you, Carol. So again, good evening. My name is Larry McHenry from Western Pennsylvania, Pittsburgh. Belong to a couple of regional clubs out here. Also, I'm a frequent visitor up to Cherry Springs State Park for Cherry Springs Star Party, Black Forest Star Party, and I've met several of you there. It's always a pleasure seeing people from around the Eastern United States and Canada there at Cherry Springs. So tonight we're going to talk about Edwin Hubble, the surveyor of the universe. 100 years ago, on the night of October 5th, 1923, a discovery was made that changed our understanding of the cosmos. American astronomer Edwin Hubble, using the new 100-inch Hooker reflector telescope at Mount Wilson Observatory, identified within the Andromeda Nebula what was to become the first extragalactic variable star. This led to astronomers adopting the expanding universe theory. Some historians consider Hubble's discovery to be one of the greatest in astronomy, on par with Galileo. Through his work of studying variable stars in galaxies, Hubble broke new ground in our understanding of the universe, and along the way sparked the basics of the Big Bang Theory. Tonight, I should say, we're going to look back on his life and his accomplishments and talk a little bit about his discoveries. Also, we'll review a number of amateur observations of Hubble objects and how you can also observe these same objects. So, high-level outline, what we're going to talk about tonight, the Island University Nebula controversy. We're going to talk a little bit about Edwin Hubble, the man, his childhood, education, his service in both World Wars, his life as an astronomer at Mount Wilson and at Mount Palomar. And then we're going to get into his specific discoveries. And then we're going to talk about how to go about making amateur observations of some of these objects that we're going to discuss here. And then we'll wrap up and conclude the presentation. So with that, let's dive into it. Island Universe, the Nebula controversy. Well, at the turn of the 20th century, one of the major questions that professional astronomers was trying to answer was this: does the Milky Way represent the extent of the entire known universe, or was it just one of many galaxies in a much larger, vaster universe? Now, two prominent astronomers of the day were working on opposite sides of this question. They were American astronomer Herbert Curtis, lived from 1872 to 1942, while working at the Lick Observatory in 1917, researching the spectrum of a prior nova that had appeared to be from within the Andromeda Nebula. Curtis uncovered 11 more examples of nova from within the nebula. Curtis determined that all 12 of the Andromeda nova had similar magnitudes, and they were at least 10 times fainter than similar nova from within the Milky Way. Taking into account the differences in nova magnitudes, Herbert calculated that the Andromeda Nebula maybe was about 490, 500,000 light years distance, which would place it well outside of the known boundaries of the Milky Way galaxy. From this, Curtis became a leading proponent of the island universe hypothesis that spiral nebulae were all external from the Milky Way, that they were galaxies in their own right. Now, on the other side of the coin, we had American astronomer Harlow Shapley, who lived from 1885 to 1972. Shapley eventually served as the director of the Harvard College Observatory from 1921 to 1952. His major accomplishments include correctly estimating the size of the Milky Way galaxy using RR, Lyra, and Cepheid variable stars and their period luminosity relationship, and also calculating the sun's position within the Milky Way as being 2/3 toward the outer edge rather than smack in the center of the galaxy, which is what most astronomers had assumed up to that time. The great debate, external galaxies versus internal nebula. Well, in April of 1920, the question of what were spiral nebula and the size of the universe came to a head. The National Academy of Sciences hosted a public lecture at the Smithsonian Museum between astronomers Curtis and Shapley, who presented both opposing papers. Shapley, of course, defended that spiral nebula were all small objects located inside of the Milky Way, while Curtis argued that spiral nebula were actually large island universes that were located far outside of the Milky Way. Now, Shapley's main line of argument and his key supporting fact was that based on observations that rotation had been observed in M101. If the M101 spiral nebula was external to the Milky Way, this visible rotation would be a violation of the speed of light. Thus, spiral nebula must be nearby and located inside of the Milky Way. Now, Curtis, though, used his Andromeda nova magnification research as his key evidence in arguing for galaxies being much further away external objects. He also used the dark dust lanes that were visible in some spiral nebula that resembled the Milky Ways as additional proof that spiral nebula were external galaxies. So, who won the great debate? Well, the general consensus of the astronomical world after the debate was that it was mostly a draw. But Shapley had the edge in that he was a better, stronger debater than Curtis was. So they give the debate to Shapley. But it soon turned out that Curtis actually had the better observational facts, as Shapley's key supporting argument that rotation had been observed in M101 turned out to be based on an old optically defective blink comparator machine, and the observations were disproven. But the answers to the question on what were spiral nebula would have to wait until another astronomer could more accurately measure the distance to them. Enter Edwin Hubble. So, American astronomer Edwin Hubble was born on his grandparents' farm in Marshfield, Missouri, on November 20th, 1889. Edwin's father, John, was a salesman in the insurance business, with his mother, Virginia, who managed the Hubble household, which included raising 7 other children in addition to Edwin. Edwin was the third oldest child. In late 1899, the Hubbles moved first to Evanston, Illinois, before finally settling in nearby Wheaton, Illinois. And then a little bit later, in 1910, they moved to Louisville, Kentucky. So they hopped around a little bit based on his dad's job. Now, as a young boy, Edwin loved to read books, especially the stories of Jules Verne. For his 8th birthday, Edwin's grandfather built him a telescope as a gift. And then 2 years later, in June of 1899, Edwin camped out all night long with friends to view a total lunar eclipse. It was said by his friends later that this eclipse is what sparked his interest in wanting to be an astronomer. By age 12, Edwin was so knowledgeable in astronomy that a letter he wrote back to his grandfather about the planet Mars was so good that it was published in the local newspaper. Now, education. So Edwin was a tall, athletic boy. He eventually reached the height of 6'3" in high school, where he excelled at the sport of track and field. He broke the state record for the high jump. But Hubble also excelled at his school studies in the sciences, algebra, and Latin. Upon graduating from high school at the age of 16 in 1906, Edwin received a scholarship to the University of Chicago, where he studied mathematics, astronomy, and natural sciences. Edwin also continued in sports, though, helping the men's basketball team win the Big Ten basketball championship in 1910. Edwin graduated from the University of Chicago in 1910 with a degree in mathematics. He then spent the next 3 years over in England as one of the very first Rhodes Scholars at Queen's College in Oxford, England, where he studied law, and he graduated from there in 1913 with a master's degree. Of course, while at Oxford, Edwin became immersed in the traditions of the English gentleman's society and dress and manners, which he adopted and brought back with him to the United States. And this is also where he learned how to smoke a pipe. Now, the summer of 1913, while Edwin was still staying in England after graduating, his father, John, passed. So Edwin had to return home to care for his mother and his younger siblings. So after spending a year teaching high school physics, getting the family on their feet there in Louisville, Kentucky, and also coaching the basketball team at a school in nearby New Albany, Indiana, Hubble decided to re-enroll back at the University of Chicago to study for a doctorate degree in astronomy. For Hubble, astronomy was his calling. So Hubble obtained a small scholarship to the Yerkes Observatory, where he worked under the direction of observatory director Edwin Frost and E. Bernard, using the observatory's 24-inch reflector and 40-inch refractor, the largest refractor in the world at the time, to photograph nebula. Also, while as a student at the observatory, Edwin had the opportunity to attend a conference of the American Astronomical Society, where he was able to meet V.M. Slipher from Lowell Observatory, who was working on obtaining spectrographs and radial velocity measurements of spiral nebula. This presentation inspired Edwin to devote himself to studying these spiral nebula. Hubble used the observatory's 24-inch reflector to photograph these nebula, and based on his PhD thesis titled Photographic Investigations of Faint Nebula, on this work, Hubble made his very first discovery from that project using the 24-inch reflector, that the brightness of reflection nebula NGC 2261 in Montesiros was variable. This nebula has since become known as Hubble's variable nebula, when some of you may have heard of it and observed it. The comet-shaped nebula is actually illuminated by the nearby bright star R Montesiros, and it's thought that the nebula's variability is caused by shadows cast by dense dust clouds that lie between the star and the nebula, and they're slowly moving. Now, Hubble also studied other nebula, though, that were located far from the glowing band of the Milky Way. He measured their individual positions, along with describing their shape, size, brightness. In the regions that Hubble studied, a number of the small spiral nebula grouped close together, prompting Hubble to speculate in his thesis paper, quote, "I suppose them to be extra-sidereal, and perhaps we see clusters of galaxies. I suppose them within our own system, the Milky Way, and their nature becomes a mystery." But Hubble was beginning to conclude that spiral nebula were actually distant stellar systems at distances from the Milky Way. Well, during his final year at the Yerkes Observatory, Hubble met George Hell, the director of Mount Wilson Observatory, who offered Hubble a job once he graduated. Well, Hubble's studies and his work, though, at Yerkes was interrupted by the United States entering World War I. After a rushed thesis, Hubble graduated with his PhD in astronomy in 1917. The day after Edwin passed his PhD exams, he wrote to George Hale about the job offer, and he said, quote, "I regret cannot accept your invitation. I am off to the war," end quote. Service in World War I. So, after graduating, Hubble enlisted in the United States Army to fight in World War I. The United States had entered the war on the side of England that spring, and Hubble, with his ties to Oxford University, felt obligated to serve. Hubble quickly rose through the ranks, promoted to a captain. He was then put in charge of training new recruits at the Army's recruitment camp in Rockford, Illinois. One of his duties was to train recruits how to navigate cross country at night by using the stars. Within a year, he was made a major, placed in charge of the 2nd Battalion of the 343rd Infantry of the American Expeditionary Forces. In September of 1918, Hubble and his troops shipped off to England and then on to France and the front lines. But before Hubble could actually make it to the battlefield near Bordeaux, the war ended. Edwin was then reassigned back to England, where he served as a judge in court martials and war reparations claims. The now 30-year-old Hubble was finally discharged from the military service in the summer of 1919. And then upon his return to the United States, he took up that position offered by George Hale at Mount Wilson. Family life. So during his high school and college years, Edwin had very few romantic attachments, and then he was too busy during the war and during his PhD studies at Yerkes. But once finally back and settled in there at Mount Wilson, he had some more free time on his hand. So he started dating a local woman named Grace Burke from Pasadena, who he had met a few years before during a visitor's tour of Mount Wilson. Grace came from a wealthy, socially connected family, and she was a graduate from Stanford University, and she found Hubble's work interesting. Grace was very knowledgeable in art, music, and architecture, and like Edwin, she was also active in sports, and the pair enjoyed going on hikes and horseback riding in the California mountains. In February of 1924, the couple was married. So when Edwin was not tied up with an observing run on Mount Wilson, which usually went for about a week once a month, he would spend time either in his Pasadena office or working from his home study. This gave him enough free time that the couple were very active in Southern California social events through Grace's family's contacts. And he actually met a lot of Hollywood stars and wealthy people and California intellectuals, including Clark Gable, Charlie Chaplin, the Marx Brothers, Howard Hughes, Randolph Hearst, and of course, Walt Disney. He made the social scene there in California. Now, a few years after their marriage, Grace became pregnant. While Edwin was away on a Mount Wilson observing run, Grace suffered a miscarriage and she lost the child. Afterwards, Grace and Edwin never had any additional children. They were content to live their lives together as a childless couple. It was said by visitors that the Hubbles were a very happy couple, extremely devoted to each other. Service in World War II. So with the United States entering World War II after the December 1941 bombing of Pearl Harbor, Edwin Hubble was asked to head up the ballistics department at the Army's Aberdeen Proving Grounds there in Maryland. The Hubbles closed up their house in Pasadena. They moved to Maryland along the Chesapeake Bay. At the Proving Grounds, Hubble was put in charge of ballistics testings of new artillery shells, bombs, developing and calculating firing and bombing tables for each type of shell, bomb, and rocket that was in the arsenal. Part of this work on the firing range involved high-speed photography of projectiles in flight and then careful measurement of the photographic plates. Hubble accomplished this by utilizing his astronomical photographic techniques that he was very experienced with. Hubble's department eventually grew to over 280 people, both civilian scientists and military personnel, and actually included 2 of the 4 early existing IBM mainframe computers. Now, the war efforts by Edwin Hubble had not gone unnoticed by the enemies of the United States. According to Grace, a military source told her years after the war had ended that a German U-boat had been intercepted and captured in the Chesapeake Bay that contained written personal orders from Adolf Hitler to blow up the Aberdeen proving grounds, along with that Dr. Hubble. Well, once the war ended in 1945, Edwin wrapped up his tenure there at Aberdeen, transferred control back to the military lead, and he and Grace closed up their house and moved back to Pasadena, and Edwin went to work back at Mount Wilson Observatory. In 1946, Edwin was awarded the Medal of Merit by President Harry Truman for his service to the country at Aberdeen. Life as an astronomer. So, going back a little bit, once Edwin was back from his World War I military service, he went to work for George Hale in Pasadena, California, at the Mount Wilson Observatory in 1919. And he was one of the first groups of astronomers to utilize the 100-inch Hooker reflector in studying spiral nebula. Hubble was interested in resuming his research started there at Yerkes and determining whether spiral nebula were just distant, unresolvable stars and gas within our own galaxy, or if they were external systems to the Milky Way. Edwin would observe these nebula with the 100-inch every clear night that he could. As part of this work, Hubble also began to develop a classification system for the nebula that he was studying. Hubble became friends with Mount Wilson night assistant and observer Milton Humason, and the two of them collaborated on a number of research projects together. Humason once described Hubble's approach to his research work as, quote, Hubble was sure of himself, of what he wanted to do and how to go about doing it, end quote. So while at Mount Wilson, Hubble developed a bit of a rivalry with astronomer Harlow Shapley, who also worked at that time at Mount Wilson studying Cepheid variables to determine whether they could be used as distance indicators within the Milky Way. Both men were interested in solving the mystery of spiral nebula, with Shapley, of course, championing that they were all internal to the Milky Way, part of his big galaxy as the universe model, while Hubble was now firmly in the camp of there being external objects. Hubble, being aware of the distance relationship of Cepheid variables, hoped to be able to discover these stars within the Andromeda and Triangulum nebula, and he searched for them using the 100-inch Hooker telescope. And then a little bit later on in his life, Palomar Observatory, while still based out of Mount Wilson years later, Hubble became one of the first astronomers to use the newly completed 200-inch Hale reflector at Mount Palomar Observatory. As part of the grand opening on January 26, 1949, of the new 200-inch telescope, Edwin Hubble was chosen to lead the first night of observing. Hubble selected the reflection nebula, NGC 2261, Hubble's variable nebula, as the first object to be imaged with the 200-inch telescope as its first light. So after a 15-minute exposure, the first astronomical photograph taken with the 200-inch was done. The plate was labeled PH-1-H, which stands for Palomar Hale Telescope, negative number 1, observer, Hubble. In addition to the 200-inch reflector, also in early 1949, the new 48-inch Schmidt telescope camera was completed, and Hubble, along with his graduate associate observers, Alan Sandage and Halton Arp, used the telescope's wide field to image and study faint nebula groups. Hubble had only completed 4 observing runs with the new telescopes when health issues got in his way. Well, after recovering from his illness, which we'll talk a bit more about, in late 1950, Hubble only made it back to Palomar twice more. Hubble continued working with Milton Humason and his new assistant, Alan Sandage, on further refining his various theories. On the evening of September 3rd, 1953, Edwin Hubble made his last observation using the Palomar 200-inch of a pair of interacting galaxies, NGC 520, also known as ARP 157, in the constellation of Pisces. So, Hubble's discoveries. But before we actually talk about his discoveries, let's just level set a little bit on what are Cepheid variables, because they're very important to this. So Cepheid variables are stars that vary their brightness by a specific range in a time frame, generally 1 to 2 magnitudes with a typical period of maybe 1 to 5 or 6 days. The very first star of this type to be identified, of course, was the fourth magnitude Delta Cephei in the constellation of Cepheus. At 890 light years distant, Delta Cephei has a period of 5.37 days and varies in magnification anywhere from 3.5 to 4.5, with a slow decline to minimum. Then it has a rapid rise to maximum. The reason Cepheid variable stars vary in brightness is due to instabilities in their nuclear fusion core. As stars similar in size to our own sun burn through all their hydrogen gas and they contract in size, they begin to burn ionized helium. Well, the initial heat energy doubly ionizes that helium gas, which causes it to absorb the light energy, making the star to appear to dim a little bit. But as the light energy is absorbed by the helium, the star becomes hotter, causing its outer layers to expand outwards, forming a red giant star, or maybe eventually a planetary nebula, which then cools the star, causing the helium to drop back down to a single ionized state, making the star now more light transparent, causing it to brighten. As the star cools again, it once again contracts, causing helium to once again doubly ionize and dimming the star. So these pulsations continue back and forth until eventually the star burns through all its helium gas and it contracts to become a white dwarf star. Now, the relationship between a star's luminosity and period of change allows astronomers to determine what that star's true brightness is, and in turn lets them determine the star's distance. This characteristic was discovered in 1908 by Henry Levin, working at the Harvard University, and is known today as Leavitt's Law. Using this relationship, astronomers were able to accurately calculate distances to Cepheids in our Milky Way galaxy using the inverse square law of light. So, now back to Hubble's discoveries. During the early 1920s, we had Edwin Hubble, one of the first astronomers to utilize the new 100-inch Hooker reflector telescope there at Mount Wilson Observatory in California. On the night of October 5th, 1923, Hubble was making a photographic observation of the Andromeda Nebula, also known as M31, using the 100-inch telescope. Hubble, again, was studying the spiral nebula, looking for any kind of change, and he's doing this by taking photographs of the nebula and comparing that evening's image with previous night's photo plates by blinking, comparing them. On one 45-minute exposure plate of a region near the core of the Andromeda Nebula, Hubble discovered a faint star that was brighter in its image than on a prior plate. Well, Hubble at first thought that the star was a new nova, as he's already had found several nova within the nebula. But after continuing observations over several nights and reviewing past plates going back to 1909, Hubble realized that this particular star, which had started to dim, had now begun to re-brighten, which was not the known behavior of a nova. The star was pulsating in brightness, which meant it was a variable star, what he's been looking for. Hubble relabeled the star as V1 on the Discovery photographic plate. This was the first variable star ever confirmed in a spiral nebula. So once Hubble was able to plot the star's light curve and identify the variable star as a Cepheid, he was able to calculate that star's distance of about 1 million light years, finding that the star was many times further away than what was considered to be the boundaries of the Milky Way, making both that star and the Andromeda Nebula extragalactic. The universe had suddenly expanded. Hubble went on to discover several dozen other Cepheid variables within the Andromeda Spiral Nebula and another 35 variables in the Triangulum Nebula, M33, and another 11 in Barnard's Nebula, known as NGC 6822. Using Harlow Shapley's own Cepheid-based calibrated Milky Way distance calculations, Hubble was able to determine that all of these other spiral nebula variable star distances, like that of V1 in Andromeda, to be much greater than Shapley's own accepted big galaxy size of the Milky Way of about 300,000 light years. Now, current modern calculations have now revised the size of the Milky Way down to about 100,000 light years, and then, of course, the distance to the Andromeda galaxy actually has grown to about 2.5 million light years. Well, prior to his announcement being published in 1925, Hubble sent a letter describing his discovery to his old rival, Harlow Shapley, who had since become the director of Harvard Observatory. Upon reading the letter, Shapley said to Harvard astronomer Cecilia Payne, who was there in the office with him, quote, "Here is the letter that destroyed my universe," his big galaxy universe. While initially criticizing Hubble and opposing Hubble's distance observations, after seeing and analyzing Hubble's data, Shapley realized that Hubble was fundamentally correct, and he became a supporter of Hubble's theory. So Hubble's observations of additional Cepheids in the Andromeda Triangulum Nebula proved conclusively that they were too distant to be located inside of the Milky Way galaxy, and that spiral nebula were in fact external to the Milky Way. The first accurate distances to galaxies had finally been determined by Edwin Hubble using Cepheid variables. Hubble had answered the old question of external galaxies versus internal nebula, and he settled the great debate in favor of the island universe theory that spiral nebula were all external galaxies from the Milky Way. Quite an important thing. So Hubble had some other discoveries too besides that. Redshift, the expanding universe. With Hubble's discovery of Cepheids in nearby galaxies, such as M31, the Andromeda Galaxy, as it was now called, this allowed astronomers to extend accurate distances throughout the local group of galaxies. But to go even further out into the universe, Hubble realized that there was a relationship between a galaxy's determined distance, its faintness, and its spectroscopic radio velocity. Working with astronomers Vesto Slipher from Lowell Observatory and Milton Humason there at Mount Wilson, Hubble discovered in 1929 that every galaxy has a measurable redshift that could be utilized in calculating its distance. A central part of today's Big Bang cosmology, this key tenet is named Hubble's law. Basically stated, Hubble's law is that the larger an object's redshift, the further away it is and the faster it's receding from us. All astronomers had to do was to measure the redshift of the galaxy, then it was just really a matter of computing the distance to that galaxy. Again, it is a critical piece of the expanding universe theory. So, how did Hubble do this? Well, using Slipher's pioneering spectrographic work, his associate, Milton Humason, was able to take a multi-night, 45-hour-long spectrum of the elliptical galaxy NGC 7619 in Pegasus, which resulted in a redshift and then a receding velocity of around 2,400 miles per second. Based on the distance-velocity relationship law that Hubble had devised, he predicted that it would be about maybe 24 million light years distance. Then Hubble confirmed this to be correct by calculating its distance using Cepheid variables that he then discovered inside of that galaxy. So he verified it by discovering Cepheid variables. Now, Hubble's discovery of his velocity distance law is considered to be the first observational evidence of the expansion of the universe and is most often cited in support of the Big Bang model. Hubble's findings established that galaxies were not fixed in their positions, but most were moving outwards away from the Milky Way at a rapid rate. Now, part of the equation that describes Hubble's law is what's called the Hubble's constant, which can be interpreted as the relative rate of the expansion of the universe. Now, a small value for the constant, say less than 100, means that the universe is expanding at a slow rate and is old. A higher value, say maybe it was over 300, would mean that the universe is expanding quite rapidly and is very much younger. Now, the current value of the Hubble constant is 69.8 kilometers per second per milliparsecs, and that gives us a universe that is calculated to be about 14 billion years old. Now, the discovery of the Hubble constant, along with the expansion of the universe, led Albert Einstein to abandon his attempts to integrate a cosmological constant into his field equations of general relativity that would have made the universe static and not expanding. Einstein later referred to his work on his cosmological constant as, quote, his biggest mistake. In 1931, Einstein made a special trip to Mount Wilson Observatory just to thank Edwin Hubble for his observational discovery that again became the basis of modern cosmology and the Big Bang Theory. And of course, while doing all this, Hubble continued his work on galaxy classification. In 1926, he devised a galaxy classification diagram based on their visual appearance, whether they were elliptical, lenticular, spiral, or irregular. He organized these shapes into a sequence of morphological classifications that he invented to help astronomers determine the type of galaxy that they were studying. This classification system is commonly called the Hubble tuning fork diagram. Hubble divided the galaxies again into three broad classes, and along with the fourth class of irregular. All the main types have subcategory classifications, and we still use a modified version of this today. So, amateur observations of Hubble galaxies. So, where can you find the galaxies that Hubble studied, and how can we amateur astronomers observe them? Well, galaxies in general can be found opposite the glowing band of light that we call the Milky Way, our home galaxy. Now, usually when we want to observe bright nebula, star clusters, dark nebula, the Milky Way is exactly where we want to look. But for galaxies, this is what we call the zone of avoidance, as all that gas and dust and nebulas and stars and whatnot in the spiral arms of our galaxy tend to obscure all these faint extragalactic nebula that we want to observe. With the exception of M31, M33, and a few dozen other bright galaxies, most galaxies are small and faint, and they do require a medium to large telescope to see visually, or maybe an imaging kit of some type. And of course, also dark country skies, such as Cherry Springs, which some of us have visited. Now, fortunately, finding and observing or imaging either M31 or M33 is fairly easy. You'll find both these galaxies plotted on nearly every type of star chart, planetarium program, handheld planisphere, or even monthly magazine star charts. And there are a number of good observing guides available to the amateur astronomer that will help you find these and many other galaxies. One of my favorites is one called the Night Sky Observer's Guide, both volume 1 and 2. These handbooks were written by George Keppel and Glenn Sanner from my club here in Western Pennsylvania. Each chapter covers a specific constellation with finder charts, sketches, images, visual descriptions of various deep sky objects, including galaxies using different size telescopes. Also, amateur astronomer Alvin Huey from the West Coast has a number of great downloadable observing guidebooks on his website called faintfuzzies.com, some that specifically covers only galaxies. One of my favorites of his is one called Observing Local Group Members, which is devoted specifically to the local group of galaxies, which includes M31, M33, NGC 6822, and a bunch of other ones. Again, it contains finder charts, descriptions, DSS images for various local group members, and on some of the galaxies, even highlights and indicates like larger clusters in these other galaxies that you can observe. Very useful guide. And of course, there's the Annals of the Deep Sky. Volume 1 has a great selection on the Andromeda Galaxy, goes into deep details of all the current astrophysical characteristics of M31. Very useful guide to have. I just hope I live long enough to see the volume on Triangulum and M33 when it comes out. Got my fingers crossed on that one. So, observing the Andromeda M31 galaxy. So here's a star chart. showing where it's located. M31, the Andromeda Galaxy, of course, is in the constellation of Andromeda, off the back end of Pegasus. The Andromeda Galaxy is the largest member of the local group. It's also a barred spiral galaxy, but the bar is oriented along the length of the galaxy. Includes at least 2 tightly wound spiral arms, has a diameter maybe about 220,000 light years, with about 1 trillion estimated stars. Now, the Andromeda Galaxy is the nearest major galaxy to the Milky Way, again, about 2.5 million light years distance. It's moving at around 110 kilometers per second in the direction of the Milky Way, which is expected to collide with in about 4.5 billion years. And here's a NASA artist rendition of what it might look like in 4.5 billion years if you were still around and looked up at the night sky. At magnitude 3.4, M31 is visible to the unaided eye as a bright patch, even from suburban locations on moonless nights, of course. On fall nights, and it's generally well placed almost directly overhead for observing with binoculars or small to medium-sized telescopes, which under good seeing conditions can reveal the galaxy's extended disk and dust lanes along with its brightest globular clusters. And even though we're very late in the season, we can still catch M31 in the western sky at a reasonable height above the horizon. So just I wouldn't wait too much longer into February to observe it. Also visible is the large star cloud NGC 206 within the galaxy, and along 2 small satellite galaxies that we know of as M32 and M110. And also a number of the galaxy's globular clusters can be identified. Larger size scopes, 15 to 18 inches or larger, will allow the observer to visually see additional internal structure within the spiral arms, including OB associations, H2 star forming regions, and again, my favorite, the NGC 206, what's been commonly referred to as a superstar cluster. Andromeda's galactic plane, again, is highly inclined from our point of view. It's around 77%, which makes it a near edge-on look, making it difficult to observe the spiral arms. But here's an example of a sketch I did using a smaller telescope. Now, observing the variable star V1. So located near the busy core of the galaxy is that dim Cepheid variable star whose discovery by Hubble in 1923, 100 years ago, led to the confirmation that the Andromeda Nebula was actually an external galaxy to the Milky Way, leading to the expanding universe of the Big Bang. Can this star be observed visually or imaged by the amateur astronomer? Answer is yes. In fact, back in 2010, over a 6-month period, a number of amateurs with the AAVSO actually observed the star for enough observations to plot its light curve. Other amateur astronomers have reported successfully visually observing and imaging V1 in various magazines and Cloudy Nights forums. So yes, it can be done. With the variable star V1, though, having a magnitude range of 18.5 to 19.8 magnitude, to observe it visually, you're going to need a very large reflector, maybe 30 inches or so. I know there's some of those things out there. You're also going to need to use high magnification. Also, you're going to need to attempt the observation from a dark sky location. You're going to need a detailed finder chart, such as this one here from the AAVSO, or you're going to need a photograph of the star's location. Again, you can find all this information online. Now, the best time to attempt the observation, again, is during the late fall, when M31 is high overhead near the zenith, and also on nights of excellent transparency. Again, with M31 kind of settling down toward the western horizon, it might be a little difficult to see this now. We're looking through more atmosphere, but I like to encourage everyone who do have access to large telescopes to give it a try. So, how do we find it? Well, we start by centering on Andromeda's core. And then you want to move to its northeast side opposite of M32. So here with core M32, you want to look for a small faint arrowhead asterism of stars that point away from the core. So again, here's the core M32. Here's that asterism of stars, triangle to get to it. Again, it has sort of a faint arrowhead of stars. There is a much smaller equilateral triangle located just off the tip of that arrow, with V1 being one of those stars. And here's some various examples. So again, what you want to do is find the general area. Let me back up here. You want to find, the core, M32, make a triangle from that, find that arrowhead, and then you can find that little triangle off the tip of that arrowhead. And depending on the size of your telescope, the transparency, sky conditions, and where the variable star is, and its magnitude, hopefully you'll be able to see it and recreate Hubble's observation. Isn't that a neat thing that we amateurs can do? Observing M33. So the M33 Triangulum galaxy, of course, is located in the constellation of Triangulum. You can also still observe this tonight, this weekend, when you go out. It's still fairly well placed in the western horizon. The Triangulum galaxy, while it's the third largest member of the local group, is only about 1/10 the size of the Milky Way, but it is the only classic shaped spiral galaxy of the local group. It has two bright, loosely wound spiral arms, along with multiple connecting spurs. M33 does not have any satellite companions that we know of today. Now, the Triangulum galaxy is about 2.7 million light years distant. It's moving at around 190 kilometers per second in the general direction of the Andromeda galaxy. But depending on the modeling, the Milky Way may actually collide with M33 just prior to colliding with M31, as M33 is modeled to swing around or orbit around M31 and right into our line of sight path. So it's going to be like a 3-galaxy interstellar pileup out there. At magnitude 5.7, M33 in the constellation Triangulum may be visible to the naked eye from a dark sky country site on moonless nights. M33's galactic plane has an inclination of about 54 degrees to us, allowing its spiral arms to be viewed without any significant obstruction by gas or dust. There's really no central bulge visible at the nucleus. Again, on fall nights, M33 is well placed overhead for observing with small to medium-sized telescopes, which under good seeing conditions can reveal the galaxy's extended spiral arms, dust lanes, bright globular clusters, H2 star-forming regions, with the largest and brightest being NGC 604. And again, when I say fall and late fall, you could still get out there and do this weekend, this new moon period. It's still in the western sky. You can still observe these objects. With a diameter of about 1,500 light years, NGC 604 is one of the largest and brightest known H2 emission nebula in all the galaxies of the local group, much larger than the Orion Nebula or the Tarantula Nebula. NGC 604 is located in the northern spiral arm of M33 to the northeast of the central core region. And finally, again, M33, you can observe it with any size telescope. Here's a sketch made of a small 8-inch Dobsonian, easily able to observe these spiral arms. NGC 6822, located in Sagittarius near the border of Capricornus. Again, this was observed by Hubble in 1924 using the 100-inch reflector at Mount Wilson Observatory as part of his search for Cepheid variables, which is why it makes it interesting to hunt for. Unfortunately, this one, maybe if you get up right before dawn, you might be able to catch it rising in the morning sky before it gets too bright. But I would just save this one for the summertime when you're out looking at Sagittarius anyways. So NGC 6822, though, is known as Barnard's Galaxy. It's an 8.5 magnitude irregular barred dwarf galaxy, about 1.5 million light years from the Milky Way. It's, again, located in Sagittarius, so it's heavily obscured by the Milky Way. Has a diameter about 7,000 light years. It does show active star formation. After the Magellanic Clouds and the Sagittarius dwarf galaxy NGC 6822 is the fourth closest galaxy to the Milky Way. Visibly, NGC 6822 is highly inclined to our point of view, but there are several H2 star-forming regions and a couple of large OB associations that are observable in medium to larger size telescopes if you have a chart showing their location. NGC 7619 in Pegasus near the border of Pisces, near the circlet Pisces. This one is still currently visible in the western sky, so you can get out and observe this this weekend. This was observed by Hubble in 1929 using the 100-inch Mount Wilson reflector. This is what he used to prove Hubble's law. NGC 7619 is a 12.7 magnitude elliptical galaxy, again in Pegasus. The bright oval-shaped galaxy is actually embedded in the middle of the Pegasus 1 galaxy cluster, which makes the whole area an interesting field in any kind of telescope to look at. The galaxy displays a bright core and is surrounded by a diffuse halo. NGC 520, also known as ARP 157, in the constellation of Pisces near the border of Cetus. Again, this one is still visible in the western sky. This was Hubble's last observation in 1953 using the 200-inch reflector at Mount Palomar. NGC 520 is a 12.2 magnitude pair of edge-on interacting spiral galaxies in the constellation of Pisces. The close bright pair has a peanut-shaped oval look to it, has a dark lane separating the two objects, and has a faint plume extending off of either end of the pair that may be visible in large telescopes or with an imaging kit. And finally, last but not least, NGC 2261, Hubble's variable nebula, located in the constellation of Montecirtos near the border of Gemini. It's well-placed early evening object to observe. This was Hubble's first discovery using the 24-inch reflector at Yerkes Observatory and was also the first light object with the 200-inch Palomar telescope. So it makes it a worthy object of Hubble's to try to observe. NGC 2261 is a 9th magnitude reflection nebula excuse me, in the constellation of Montecirtos, located next to the variable star R Montecirtos. The nebula has a comet-shaped appearance with the bright star appearing to look like the head of a comet. Very interesting object to look at in telescopes. Hubble's legacy. So, over the years, Edwin Hubble received various awards and medals for his work. These included the Cleveland Prize in 1924, the Barnard Medal in 1935, the Bruce Medal in 1938, Franklin Medal in 1939, the Gold Medal of the Royal Astronomical Society 1940. In 1927, Hubble was elected to the National Academy of Sciences of the United States. 1928, he was elected to the Royal Astronomical Society of Great Britain, the Vienna Academy of Science in 1947, and the French Academy of Science in 1949. So he received a lot of awards and accolades for his various discoveries. Now, throughout their marriage, excuse me, both Edwin and Grace continued with their athletic outdoor activities. They enjoyed playing tennis, swimming, horseback riding, hiking, and fishing. Edwin was an avid fly fisher. He loved to fly fish. They enjoyed traveling to remote areas of the country for scenic wilderness vacations. They enjoyed spending time outdoors together with each other. Well, during the summer of 1949, after a successful observing run at Palomar, while vacationing on a fishing trip near Grand Junction, Colorado, the 59-year-old Edwin suffered a sudden heart attack. It took several hours to get Hubble down off of the remote mountain where they were at, make the 100-mile drive to the nearest local hospital. So, which those of you know, that's not a good thing when you have a heart attack. You really need to be in the hospital within the first hour. While recovering there at the local hospital, Hubble suffered a second, even more serious heart attack, and he actually lost part of his heart function. The local doctors didn't think he would survive, but Hubble pulled through, and after about a month, he was able to return to Pasadena, where he spent the next several years regaining his strength. Hubble was eventually able to return to work part-time at the Pasadena office, but he could no longer work long, multiple nights in a row on the cold, high altitude at either Mount Wilson or Mount Palomar mountains. The few trips that Edwin was able to make up to the mountains observatories, Grace would accompany him and stay overnight with him, along with Edwin's observing assistant, Alan Sandage. Then, September 28th, 1953, while being driven home from the office by Grace to have lunch at home, just as they were pulling into the driveway at the house, 64-year-old Edwin suffered a stroke and died right there in the car from a cerebral thrombosis. Now, years earlier, Edwin had told Grace that when he died, he wanted to, quote, disappear quietly. So, honoring his wishes, Grace had Edwin cremated, and there was no funeral or memorial service held for Edwin. Hubble's ashes was buried in an unmarked location known only to Grace and 4 other people. It's said that when Grace herself finally passed in 1980 at the age of 90, that her cremated ashes was placed with Edwin's. As of this date, the 4 remaining people have all themselves passed on, leaving no information or clue as to where the Hubble's final resting place is located. There is no cemetery monument honoring the greatest observer since William Herschel, but his discoveries still live on today. So, in conclusion, Edwin Hubble is considered by some to be one of the great American observational astronomers of the 20th century, whose discovery of extragalactic variable stars led to a deeper understanding of our expanding universe. In just a 10-year period from 1923 through 1933, Hubble confirmed that spiral nebulae were actually all external galaxies. He developed a general classification of those galaxies, and he discovered the expansion of the universe, confirmed the redshift theory, leading to today's Big Bang cosmology. Few other astronomers, besides perhaps Copernicus or Galileo, have had such a revolutionary effect on our knowledge of the universe. So I encourage everyone to get out tonight or tomorrow night, try your hand at finding and observing the island universes of the Andromeda and Triangulum galaxies. And while doing so, think about the man whose observations that October night, just 100 years ago, led to the Big Bang Theory. Edwin Hubble, the surveyor of the universe. And with that, if you'd like to learn more about Hubble, there's lots of great books out there, magazine articles about it. You could read his book, The Realm of the Nebula, from 1936. Still an interesting read, though a little bit dated in some respects. Again, all the magazines, Sky and Telescope, Astronomy, so on. Every so often they have articles about Edwin Hubble or how to observe M33 or M31, etc. There's lots of great internet resources out there. Just Google Edwin Hubble. You'll find all kinds of great information out there about the man. If you'd like to see more examples of my amateur observations of the local group galaxies, which includes Hubble's galaxies that he observed, you can go to my website, stellar-journeys.org, scroll down to local group galaxy tour, and I'll take you to another page. If you'd like to read this presentation in much more detail than I could go through tonight, go down to my PDF download page, and there you'll find this presentation as a PDF document that you can download and read, and especially good on nights when you have trouble getting to sleep. And finally, there is actually a handout that would go with this presentation if I was there in person, Hubble objects you might see tonight, and you can download this also from my PDF download, and just gives you some examples of things to look for in M33. You can look for NGC 604, that giant H2 region, and also gives you a little high-level finder charts for how to find the variable star V1 in Andromeda, and of course NGC 6822. So that concludes my presentation on how Edwin Hubble, the surveyor of the universe, and how us amateurs can observe these objects. So at that point, I will turn the floor back over to Tony, and I'll be happy to take any questions that you might have about Edwin Hubble. Thank you.
All right, so do we have some questions here?
I have a not so much a question as a comment, but great talk. Thank you very much. I just wanted to point out that Humison had 1 week of high school before he became a mule skinner to take all the equipment up to Mount Wilson. And then he became a janitor on Mount Wilson. And then he became a telescope assistant on Mount Wilson. And then he assisted Edwin Hubble. And he did the spectroscopy. Edwin Hubble did the Cepheid variables. But I'm really happy you mentioned Humison, because he was kind of an amazing, underachiever that overachieved.
Yeah, interestingly, Humison was actually originally hired as a mule driver when they were building Mount Wilson, and he just sort of had a natural inclination. He was interested in things, and they hired him on as like a night janitor, and he just slowly progressed and became a professional astronomer in his own right. Hey, any other questions or observations?
Yeah.
Yeah. So as you mentioned that the pictures that we are seeing today, they must be many, many millions of light years behind, because light takes time to travel. So if you predict that we are going to collide with Milky Way, we may be almost there.
Tony, I have to ask you, can you please repeat that? I can't hear the audience very well.
Can you hear me now?
A little bit louder, a little bit louder.
I can come closer. Very nice presentation. Thank you so much. So you predicted that some of these galaxies will hit the Milky Way in billions of light years. So the pictures that we are seeing today, they are many, many millions years ago. So do you think that they are already on the way to hit Milky Way?
I'm sorry, my cold kicked in right when you were talking. I had to get a cough out of the way. I was still only catching like every other word you were saying. Tony, could you possibly repeat what she was asking?
Sure. She said the images that you showed of the galaxies, Andromeda and the Triangulum, they are as they were billions of years ago.
Correct. So and all those images, you can probably tell a few of the older ones, the professional images. Most of the images I showed tonight were ones that I have captured using EAA techniques, or video astronomy, as we used to call it. But when you look at that picture of Andromeda, say I made it tonight, that was 2.5 million years ago when that light left. It took it that long to get here. So that is kind of mind blowing when you think about that. That who knows what the galaxy really looks like these days now.
Yeah, that was her question, is will it be here sooner than we expect?
Yeah.
Because we're seeing it as it was in the past.
But it's only
Right. Yeah. So
not 4 billion.
Okay,
It's only 2,000 of that time span.
Okay, 2 million light years.
yeah, about 2.5. They every few years they recalculate the distance, tighten it up a little bit. But even like the nearest star, you look at if we were down south and we could look at the nearest star, Alpha Centauri, that light took 4.5 years to get to us.
Sure.
But good question, yeah.
Yes, sir.
Given the fact that the Hubble constant has the universe at approximately 14 billion light years in size. What about the recent information we've been getting from the James Webb Telescope that doubles that number?
So 14 billion years old, I think, is what you're referring to. And again, that's based off the Hubble constant, what they calculate for. And I know every few years, again, they kind of recalculate that. That kind of changes a little bit. I'm not sure if I'm really answering your question or not, to tell you the truth. I'm just not a professional astronomer. I don't know the math that well enough to really explain it, I think, at the level that you're looking for.
More questions? Any questions online? All right, well, thank you very much, Larry.
Thank you. Appreciate, Tony, you having me once again. Speak to the Rochester Club. It's always a pleasure. And with that, I will mute myself. And if anybody has any questions, I'll be here till the end of the meeting. If not, you can always pop me an email. I'll be happy to answer it later on.
I
Thank
got
you.
one question for you, Larry. Where are you going to be for the eclipse?
Where am I going to go for eclipse? I'm going to the Lake Erie. I'll be in the town of Erie, right on the lake shore.
All right.
Yeah, actually, when Kevin asked me to do this talk, I gave him a couple of options: this talk and one on where to go for the solar eclipse. So, but I had the impression you guys have kind of had your fill of eclipse stuff, so we went with this talk. But we're in Pittsburgh here. We're at like 97%. So got to go north to get to it. And something that I've experienced myself numerous times, one with the Venus transit and also sitting at my favorite winery along the shore of Lake Erie, is what's called the reverse lake effect, where as long as the lake isn't frozen over in the wintertime, the water moderates the air above it and basically causes the clouds to evaporate. And that clear sky extends maybe about a mile or so from shore, and then the air condenses out, forms clouds, rains on you, snows on you, and whatnot. So again, I've experienced this many times sitting on the shore at my winery, having a glass, while 6 miles back at our bed and breakfast, it's raining. So I'm telling everybody to go to the lake shore, and you get that both Lake Erie and also Lake Ontario, where you guys are at. So good luck with it. I hope we get clear weather and not a big northeaster.
Yeah, for real.
All right. Well, thanks again. I'll
Thanks,
stick
Larry.
around.
If anyone wants to come up and ask him questions using this mic after we wrap up here, feel free. I'll leave the meeting going for a little bit. How many we
Thank
got
you.
online? 20 and